Hello students, welcome back. Previously we went through the product rule. The derivative of the first function times second function plus first function times the derivative of the second function. Some examples include like this. Bracket, that's a derivative. Bracket is a derivative. Parentheses, just copying and pasting. And previously, let's write like this. So derivative to be here, and the derivative to be here. And then this one and that one, those parentheses are just copy and pasting, so no big deal. And here we have the derivative computation of the first function. There, the derivative computation of the second function, which we did here. Likewise, you can set up like this. The derivative times the second function copy, and first function copy, and the derivative here. Now calculate the derivative of the first function. That'll turn out to be this. And calculate the derivative of the second function. That'll turn out to be that. So get the structure and then fill out those brackets. It works for me. It helps me cutting down mistakes. And let's do the same thing to quotients. So this is the one. And let's expand the font. And look at this. We need denominator squared. And then in the numerator, I have something very, very close to the product rule. The derivative of the numerator times the denominator minus derivative of the numerator times the derivative of the denominator. Parenthesis, I'm just copying, so that's the denominator, t to the fourth power minus 2. And this is the numerator here. So t to the third power plus t. So those are just copying. As for the derivative computation, we have this and that. The numerator, what do you have here? T cubed plus t. 3t squared plus 1. And that's the derivative of the numerator. Can you read it? And then let's take the derivative of denominator. 4t cubed minus 0. And you don't have to write plus 0, right? So let's just remove that. That completes the problem. So get the structure first. Bracket and blank, and then fill those in. That helps cutting down mistakes. At least that was my experience. Let's do it one more time. We need denominator squared. That's so conspicuous that barely anybody misses it. The numerator, well, u prime v minus u v prime. So u prime, that's the numerator. And the denominator here, well, let's see. Copy and paste. And the numerator here, copy and paste. And then the derivative of denominator here. So this is just copy and pasting, so it doesn't require any kind of calculus, just a structure. And then let's work out the derivatives here. The derivative of the numerator. X squared, so that becomes 2x. And then exponential always stays the same. There goes the derivative of the numerator here, highlighted in blue. Here, I need the derivative of the denominator. How do I do that? X becomes 1, and the derivative of log function is 1 over x, or x to the negative first power, whatever method you want to use. Me personally, I like power form better, but a lot of people prefer 1 over x. Either way, it'll work out. So, we went through some quotient rule. Enough time for some generalized product rules. We have three things, and then 4 things multiplied. No sweat, just a derivative, same, and then derivative, same, derivative, same, in those places. We have 3 factors, so 3 things has to be added. So what do you have here? F prime of x, f prime of x is the derivative of the first function, and the other must be the same. And let's put parentheses here as well. And then next, the same thing here, except that this is a derivative. And then the same thing, except the last one is a derivative. Okay, that's the structure. And then let's put in the derivative. Derivative of the first function, 1, that's constant, that goes out. Here we have e to the x power. Next, derivative of the second function, x becomes just 1 minus 2, and then 1/2 power. Negative 1/2 power, after subtracting 1 from there. 2 times 1/2 is just 1, so that's what you're going to get. That's the derivative of the second function. And finally, the derivative of the third function, x to the negative first power, if you prefer the power form. I do. Otherwise, you can put 1 over x there. Either way, it'll work out. I usually use parentheses for just copying and pasting, so I don't really think. And then bracket, okay, that's a reminder. The derivative computation must go there. I have to do it once, twice, thrice. The second problem here, I have 2x square root of x, e to the x log of x. As a matter of fact, x times square root of x can be put together as x to the 3/2 power. So again, we have 3 functions. This one here, we're going to have the product rule with 4 factors. So it's going to be like this. The first one here is going to be a derivative computation. And then next, the second one here is going to be the derivative computation. And then third one here is going to be the derivative computation. And then finally, fourth one here is going to be the derivative. And then do the computation and plug those in. First, second, third, fourth. Put those in and you're going to get the answer. What's the answer? First, second, third, fourth, which are highlighted in blue. Are those correct derivatives? Well, that's left to you. Each derivative computation follows from exponential and power. Sometimes we have natural log, but mostly power rule and some exponential rule. So generalized power rule, as a matter of fact, is not too bad. So we did quotient rule and some generalized product rule. You have time for tangency? Oh, okay, we have a nice quotient problem, so let's work on it. All right. Tangency. What do we want? We want this. Y equals to m slope x minus x naught plus y0. That's what we want. Point x naught, y naught, and then slope m. X naught is given as 4. So y naught, oops. Oh, sorry about the typo. Okay, y naught plug in x equals to 4. Square root of 4 over 4 minus 2. And what is this? 2 over 2. An easy computation. So that's 4 and that's 1. You see, the answer will look like this. Y equals to m x minus 4 plus 1. And of course, we don't have this one yet. How do you get the slope of the tangent line? You have to take the derivative. So what's the derivative of this quotient? Well, that's where the quotient rule is coming into play. Expand the font a little bit. Denominator squared. And if we have u prime v and then u v prime. That's the derivative. So what's the derivative of square root of x? X to the 1/2 power. So by power rule, 1/2 x to the negative 1/2 power. How about the derivative of denominator? Oh, that's easy. That's just 1. Okay, all right. So that's the derivative. Therefore, the slope is this thing evaluated at x equals to 4 in this case. X naught is 4. So plug in 4 here, plug in 4 here, and 4 to the negative 1/2 power there, and the square root of 4 there, and then do your computation. Punch everything into calculator. I got a little bit tired, so instead of trying to do this with mental math, I'll just put everything into calculator. I get negative 3/8. Is that you're getting? So using the quotient rule, you can calculate the derivative and plug in the number and you get the slope. The answer here, I have 3/8. Negative 3/8, and that completes the problem. Slope point equation. Let's see, what do we have here? Yes, the very same process. And looks like here's a visualization. We have a tangent line there as well. Okay, everything looks good. Here's the solution. Same process, same answer. Step 1, point. Step 2, derivative, quotient rule. And step 3, slope. Step 4, the equation.